A batter hits a fly ball which leaves the bat at zero point 0.9 meters above the ground at an angle of 61 degrees with an initial speed of 28 meters per second heading towards center field. Ignore air resistance. A. How far from home plate would the ball land if not caught? B. The ball is caught by the center fielder who's starting at a distance of 105 meters from home plate. Runs straight towards home plate at a constant speed and makes the catch at ground level. Find his speed.
Okay, so the first thing that we're going to do is we're going to set up the path of the ball. So we have the batter hitting the ball at 9.9 meters above the ground level, and then we have the batter hitting the ball at a 61 degree angle with initial velocity of 28 meters per second. So we're going to set up our table, and initial velocity for x is going to be the velocity times the cosine of 61 degrees, which comes out to be 13.57. And then you do the same thing for y, 28 times the sine of 61, which comes out to 24.49. Then your acceleration for x is 0, and your acceleration for y is negative 9.8. Your distance for x is unknown, and for y, your displacement is negative 0.9 meters. So for A, you're going to find, the first thing you have to do is find time. So you use the change in distance, velocity times time, times half acceleration times time squared, and you find that your t is 5.03 seconds. There is also the other time of negative 0.036 seconds, but since that answer is impossible, we discard it. Then in order to find the range of the ball, you use the same formula and you substitute the time in, and you get distance to be 68.2571 meters. And you keep all the decimals that will be used in Part B.
So for Part B, you basically have to find the velocity of this catcher in order for him to get from his point 105 meters away from the home plate to the point of when the ball hits the ground. So we just found the amount of distance that is elapsed in Part A after when it'll hit the ground, basically. So you need to find the difference between him and that point because he's catching the ball at the ground. So he's finding it after 68.2571 meters have been passed. So in order to find the distance he has to run, we simply subtract the 68.2571 from 105 to find the difference here, which comes to 36.7429 meters. And then you simply plug it back into your kinematics equations with the change in distance equals VIT plus 1/2 AT squared. And your change in distance is 36.7429 because he's running that distance. And then your time is going to stay the same because it's the amount of time that it took for the ball to go from the batter to the ground. So that's 5.03 as we found in the last equation. And then your acceleration is 0 because he's running at a constant speed, so he's not increasing or decreasing anything. And then your time, once again, would be 5.03. But this cancels out, so you're left with 36.7429 equals 5.03 VI, and then you divide by both sides, and then you get 7.305 meters per second.